Good afternoon, all. Am I audible? Hope you people are there.
Good afternoon, sir.
So only 20 people have joined. Okay. So it is the really bad thing. People are not joining on time. So today we'll start about this Coulomb's theory. Okay. Visible? Should I continue?
Yes, sir.
So we will not wait for others. Okay. Because it is their wish. I think people are not sincere to join on time. Look at the time. Okay. Very casual. Anyway, you will see in the exam. So in today's class, we'll focus on this Coulomb's theory, as I said. Okay. So before going to Coulomb's theory, we just see the what are the assumptions he has made it. So Coulomb's 1776 developed a method for determination of the earth pressure in which he considered the equilibrium of the slide wedge. So wedge he has considered, okay, which is formed when the movement of retaining wall takes place. Okay, so backside of the retaining wall, he says that there would be a wedge like Rankine only. Okay, and before wall try to move away, the active case in the active case walls will try to move and the sliding wedge will move downward. In the passive case, it moves in the opposite direction, upward. Okay. So he has made some assumptions. The analysis is type of limiting equilibrium, okay, method. So in passive case, slightly moving the upward. So these are the assumptions he made it. The back of fill is dry. It is a cohesionless soil, especially first case, okay, and isotropic and ideally plastic material back of the wall. And surface of slip is plain, okay, which passes through the heel of the wall. Anyway, I will show that picture. So the wedge is passes through the failure plane is passes through the uh, heel of the wall. The wall surface is rough. This is very important, as I said. The wall surface is rough. So Rankine assumed that this wall surface is the Rankine assumed the wall surface is smooth and the vertical, and this particular guy assumed that the wall is rough. Okay, this is very important. The wall surface is rough and the earth pressure on the wall is inclined at an angle of delta. So whatever the Rankine has done a mistake, what he has done is he considered the wall, the Rankine considered the wall vertical and this Coulomb's theory considered the wall inclined. Even Rankine also considered, okay, previously I have shown him. And he has considered the back of the wall rough and he considered the equilibrium of this wedge. Okay, and he analyzed and he found out this the Ka value. That is more important. Okay, if it active case Ka, Kp, K naught, Ka and Kp. At rest, active case, passive case. This case K term is changing for everything. Okay, K naught is 1 minus sin phi, Ka is 1 minus sin phi by 1 plus sin phi, Kp is the reverse of that, 1 plus sin phi by 1 minus sin phi. So here, and the sludging wedge itself act as a rigid body. The back of the sludging wedge, the sliding wedge will act as a rigid body. And we can apply our statics equilibrium conditions like we have done for our engineering mechanics. Same thing we can apply and we can find out the active pressure on the wall. So the magnitude of the earth pressure is obtained by considering the equilibrium of the sliding weights as a whole. Okay, Coulomb's theory, a failure plane surface is assumed and the lateral force is required to be maintained. So what we'll do is he has done the trial and error method. So he assumed some failure plane and he considered the wedge and again and found out the what is the active pressure. So like that trial and error method he has done it, where he got the active maximum active pressure. That particular pressure is represented by the active case. That's what it is written here. The trial surface which gives the largest force for which active case and the smallest force for the passive case is, is the actual failure. So this particular method readily accommodate the friction between the wall and the backfill, irregular backfill, sloping wall, surcharge load, and so on. So this particular theory is superior. Although the initial theory was for dry cohesionless soil, it has now extended to wet soil, cohesive soil, and so on. This column theory is more general than the Rankine's theory. So this is more general than the Rankine's theory. Okay, so he assumed the wall becomes rough, an inclined wall. He has considered that the weights and so on. Yeah, and finally he found the active earth pressures. Okay. So see, look at this one. Coulomb's theory for active pressure for a cohesionless soil. Okay. So here, anyway, I will show that picture, and we'll consider this back as the incline and the granular. Maybe next page I'll go. Okay. So this is what the Rankine active earth pressure. So here, what he has done is he has considered the wall as the slope, ground also slope with inclination I, and what he says is this is coming down. Okay, so here this particular wedge he applied the same mechanism what we do, the static mechanism, and this is W is the weight. There are two reactions here, R and the PA. Our interest is on PA. Okay, so it is active pressure, which is nothing but the reaction. Here it is acting. Okay, this is a reaction. So what he says is this active pressure is, okay, he assumed that makes an angle with the normal, makes an angle delta with the normal. Okay, so makes an angle this delta with the normal, this active pressure case. And here the reaction makes an angle with the phi. So he assumes some angles. So he says that alpha is the slide, various alpha means this is the first case you can say. Okay, then again one more he will assume it, one more failure plane trial and error and find out this active case. So this failure plane makes an angle with the alpha here, this wall makes an angle beta. Okay, it's not okay here, not beta, this is the B point, this is the A point, B point, And where is the C? This is the C and this is the D. It's not beta, okay. Beta, this one is the beta. So A, B, C, D, and where is hope it is clear, okay. This is A point. So this is the B point, this is C, and this is D. So they have, what he has done is he has drawn the normal for both the cases, and he says that with phi this R reaction takes place when, because slide is moving down, okay, that, and this is the we need to find out, okay, which makes angle delta, okay, and this will make angle with phi, the R term, okay, R. And what he says is this is the alpha, he assumed it, and this is the gamma he assumed with the vertical, and with the vertical it would be beta, okay, and this is the I. Understood? He assumed alpha, beta, gamma, some angles he has assumed it, okay, with vertical and the normal and so on. Then only we can analyze it. So this is the alpha, and this is the phi, this is the gamma and the delta, and this is the beta with the vertical, this is the beta. Now if you do this static analysis, if you look at here, weight W, here it is acting, okay, center of gravity. From center of gravity he has drawn the vertical to this, okay. Here he says the PA would be acting, and sometimes he will consider if this is the H, okay, H by 3, mostly it will act at the H by 3. So by using this particular analysis, static analysis, now look at here, W triangle we have drawn, okay, W is coming and this is R is going in this direction, this R, then this is PA, okay. What is the angle between this one? Alpha minus phi dash. Look at that. Sorry, alpha or gamma, whatever you call it, okay, alpha minus phi dash. Whatever the angle here, we have assumed one more term xi, which is nothing but the beta minus delta. This should be 180 minus all these things, this angle, 180 minus this and this. Now this equilibrium triangle we have drawn it, and what we do, we can do this sine formula. Using that one we can find out the PA. That's what they have done it, okay. This anyway I will show it, okay. Let me read these points what he has mentioned. So before going to the next page, so here W weight, reaction R and the slip, and these wall. Here if you read these points, that's what it is mentioned, okay. It may be noted that the failure condition, the shearing resistance on the failure surface is fully mobilized and the reaction R has been the maximum obliquity, okay. It is therefore inclined at phi to a normal to the failure plane, and PA acts upward, it is inclined, okay, it is inclined and at an angle delta to the normal, sorry. And figure 19.24 shows the force triangle as the magnitude of the force, one force, and the direction of all the three forces are known. For a triangle can be, force in a triangle can be completed, okay. So the magnitude of PA is determined from this force triangle. The pressure acting on the wall is equal to the and the opposite in the direction. Whatever we find out PA in the on the wall would be equal to the opposite. So we are representing the opposite direction, this PA. The procedure is repeated after assuming in other failure plane the surface that gives the maximum value. This is important. Is the critical failure plane. Okay, with that maximum value, if we get it, that particular force is called the active earth pressure acting on the wall. So corresponding force is active earth pressure. So Coulomb's method does not give the point of application of the resultant earth pressure. The point of application is found to be approximately at the point of intersection of the E of the back of a retaining wall with the line C drawn from the centroid of the C of the failure wedge and parallel to the failure plane surface. And that's how I have shown you, right? So sometimes you will take H by 3 also. As this procedure is cumbersome, for convenience, the pressure distribution sometimes assumed to be hydrostatic on the back side of the wall and the resultant pressure assumed to be 1/3 of the height. That means height to 1/3 mean H by where it will act. Okay. From the base, the following points should be carefully noted while using this Coulomb's theory. What are those points? For most practical cases, the backfill moves downward related to the wall in the active case. And however, if the wall is supported on a soft and the compressible soil, it may settle to such an extent that the movement of the wall, okay, will be downward relatively to the back of the backfill, and the relative movement of the wedge may be upward. In that such case, PA could be taken in the inclined to a delta above the normal. That means this is the wall, right? Sometimes no, when the wall try to sink in a soft soil, then these wedge may move up. Then in the reverse direction, we will take it. Understood? That's what it is given. So the angle. So the angle is the friction angle between the soil and the wall. Whatever delta I have been telling you with that, right? So this delta is there, right? So this delta in the wall, okay, this is not phi actually. This is the friction angle between the soil and the wall. This is a friction angle between the soil and the wall. Generally, we will take this delta as 2/3 of phi dash or phi dash. That's what it is given here. It may be determined by means, so phi we can determine by using the our direct shear test. Okay, if it is a C5 soil, if you conduct the direct shear test, you will get this phi, and this is the psi C. Okay, purely cohesive soil, we can get this phi value by using the direct shear test. Okay, so once you know the phi, we can find out the 2/3 of the phi would be delta. This particular point is very important. Okay, again maybe useful for your gate. 2/3. Generally, delta will be taken as 2/3 of this phi value. If the friction delta is 0, okay, in that case, whatever we are assuming, we are calculating this particular value exactly will get as a Rankine value. That's what it says. Okay. If the friction delta is 0 and the wall is vertical and the ground surface is horizontal, the Coulomb's method gives the identical result with the Rankine's method. That means whatever suppose we are assuming the wall is uh, vertical and the smooth, delta equal to 0, then exact value you will get it like a Rankine's value. So whatever Rankine done the mistakes, this Coulomb's fulfilled. Okay, so that's the meaning of that. Coulomb's theory assumes that failure surface to be plane. The actual surface is slightly curved. That means we assume that backside of the wall, we assume like a triangle. Okay, so straight line. Sometimes it may be like this also, little curve. The failure plane. Okay, failure plane can be curve also, but we'll assume it as a. That's what it is happening in the landslide. If you go and see landslide, what is happening failure where exactly you will not get a straight line. Okay, so there may be, it may be curved. So fortunately for active case, the error may be less, okay, because whole wedge will coming out, and we say that it is a, uh, I mean say vertical. Next, now, so if you look at this one, what they have done is here. So 19.24. That means the previous this one, from this one they have derived it. Okay, so from, if you are okay with this triangle, okay, this triangle, by using this triangle, by applying this sine formula, so they have derived it. So using the this one figure, PA by alpha minus phi, W by, as I said, 180 minus all those angles. Okay, then you will get the PA. This is the active pressure force. Here in this case, what is unknown to us? Unknown to us is W, weight. Other things are well known to us. Okay, we assume some failure plane, alpha, beta, gamma, whatever is there. Okay, and phi value we can find out from the laboratory test. This particular weight is the very big problem. How to find out the weight? Okay, so what he has done is he has taken this again wedge ABD, AB should be D. So weight of the weights A, B, D, it should be D. Let us see. Okay, he has mentioned it, determine. So here he has given D, but it must be E. Okay. So here what he has done is he assumed that wedge. Okay. And what he has done is beta, this is the beta, he assumed it, makes alpha. This is 180 minus beta minus alpha. He, what he has done is he's drawn a vertical here and he made it like a G, I think. Okay, this is a vertical 90 degrees. This, then this would be, if this is alpha minus I, that is 90 minus alpha minus I, and if this is the uh, beta plus gamma minus 90. So he has assumed these angles. Okay, so by using this one, what he has done is he's tried to find the weight. He tried to find the weight of the soil. Okay, he assumed the weights. After assuming the weights, what is happening is here is, so W is nothing but the half into base into height. Half BE, now he has written BE into height, nothing but the AG, multiplied by unit weight of the soil. Gamma is unit weight of soil. That's all, is it not? Area or a volume. Volume, why we are not assuming volume? Because we are considering plane surface. Okay, a meter run we can assume it. Meter run or meter per meter. So what is the unit weight value? This is kilonewton per meter cube and multiplied by area kilonewton per meter, we will get it. Okay, the weight per meter we will get it. So here half into base into height, and he, by taking AG as M, some short term, okay, short method is taking, assuming some parameter, AG as M, the AG length as M, BE length as the L, the BE as L. We can write this formula in this way, or we can make it this as the half into M into gamma plus BG plus GE. L is nothing but the BG plus GE only, right? BG plus GE, nothing but the L. And he has assumed that H as the height, and this is the beta. How we can write out this AB? where is this A and B can be written as h by sine beta. If this is the beta, right? If this is the beta, then we can write it as the h by sine beta. And from the triangle ABG, look at the ABG. We can write it as the m by AB, which is equal to sine 180 minus beta plus alpha, which is nothing but sine beta plus alpha. M is equal to AB sine beta plus alpha, which is nothing but the h sine beta by sine beta. From the triangle ABG, okay. So from the triangle ABG, further we can write it as BG by this one, and BG can be written like this from the triangle AG. It is not very difficult, okay? Just go through it. It's not very difficult. You have clear all. So just by using this assumed amine, L he has assumed it, and finally what he has got it, this particular weight. By substituting the values of M, BG and G from those equations, okay? So this is the weight we have to find out. So here now, so this is our weight, right? So this is our weight. So this W, you just take it and substitute there. This particular W, what you have to do is you have to substitute there where unknown was there, no, the W. Then you will get this equation. Now this what we have done is we have assumed some one failure plane, but it's a trial and error method. In that what we have to do is the failure plane what we are assumed, the weight should give the maximum pressure on this wall. So what we have to do is we have to differentiate it. The active pressure force PA will be the maximum when the failure plane makes an angle alpha. Okay. Then what we have to do is delta PA by delta alpha is equal to 0 to make it this PA maximum. Understand? Okay. Then what we have to do? We have to solve this equation. So this Muller and the Bresler gave the solution for this one. Whatever we are differentiating, right? It's a big solution. You can do it. If you have a computer, you can do it, okay? Or you can try on yourself also. What you can do is this fellow has done it and he has given this equation solution. So this is very easy for us. Only difference is here half into K gamma H square, H we know, gamma we know, K we know, 1 by 2. What is this K? This is the K. Understand? What is this K? This is the K. Very big. So that's what we are interested, right? So this K, once you get the K depends on the alpha, beta, gamma, phi, and so on, inclination of I, and so on. Well, we know all these things. We know unit of the soil, H we know, and we can find out this active earth pressure. So where it will act from the H by 3. That's what it is given. Okay. So the line of action of the PA will be at a H by 3 above the base of the one. It will be inclined at an angle of delta from the back wheel. Okay. So this particular thing would be acted, and where it will act with a delta to the normal with the H by 3. So this is the story about the Coulomb's method, where he has assumed the wall is rough and the incline and the surface also inclined with inclination of I. Okay, the surface also he has assumed incline. and you gave the solution K naught. Okay, active earth pressure Ka. So with that, I'll stop today. Hope you are following and try to read the Aurora book. It is given in very detailed. Okay. So all our classes I am uploading it. Okay, to our so it is uploaded, and I'll stop the recording and I'll take the attendance. Okay.